In this video, I'm going to remind you how to find the slope from a table of values. Now, it would help if you remember what slope is. Slope is just a measure of the steepness of a line. And when we talk about how steep a line is, what we're really just doing is comparing the vertical change to the horizontal change. In other words, how much is the line going up compared to how much it's going across. A lot of times we'll compare the vertical value to the horizontal value. More formally, we'll say that the slope is the change in the dependent variable y compared to the change in the independent variable x. When we abbreviate that, we might write the change in y over the change in x. If I abbreviate it still, I would use the delta symbol. That's this triangle right here. That represents the change in y over the change in x. Still a comparison of two numbers. Or, like I said a minute ago, we can compare the vertical number to the horizontal distance. Or, quite simply, rise to run. This is probably the most common way you'll see slope referred to in a math classroom. How is the line rising compared to how it's running? Now, that's all fine when you're looking at a line in a graph, which the purpose of this video is to show you what you do when you're looking at a table. But still, it helps to look at a graph and then compare it to the table. So that's what I intend to do here. I'm going to give you some points to look at in this graph, and I want you to consider if I were to draw a line going through those points, I could talk about how that line is changing vertically compared to how it's changing horizontally. What I would do is I would look at my first point and I would say, how much do I go up compared to how much I go across? Or what's the vertical change compared to the horizontal change? That's what we mean when we're talking about slope. But I want to focus on the values. I want to focus on the numbers, the actual coordinates of x and y. So the coordinates of the 3 points in this graph are -3, 1, -1, 4, and 1, 7. I'm going to take those coordinates, I'm going to put them in a table. So it would look something like this: -3, 1, -1, 4, and 1, 7. So what we're really going to do is we're going to compare the slope of the line by looking at the table and then focusing on how the y values are changing compared to how the x values are changing. Again, that's what we mean when we say delta y, the change in y, compared to the change in x. All right, let me show you an example. If you're going to be asked to find the slope from a table of values and there's no graph, there's no picture to look at, what you want to do is you want to focus on the y values independently and the x values independently, one group at a time. So let's focus right now on the y's. I want you to look down the y column and ask yourself, how are those numbers changing from step to step? In other words, how is the 17 turning into an 11? Well, it looks like we're going down 6 units to go from a 17 to an 11. To go from an 11 to a 5, we're going down 6 units. And again, down 6 units to go from a 5 to a -1. Then we change gears and look at the x column. When I look at the x column of numbers, I see that the 7, the -7, is changing by 3 units to go to a -4. Or I would say it's increasing by 3. To go from -4 to a -1, we're increasing by 3 again. And then to go from a -1 to a 2, we're increasing by 3 again. So when we talk about the slope in the change in y compared to the change in x, we'll say that all of the y values are changing by 6 units, -6 units, and all the x values are changing by 3 units. So I would continue, I would reduce, and I would say the slope of the line that's represented by this table is -2. That means down 2 units for every 1 unit across. Let's take a look at another example. Same situation, a table of values. Now you could be given any length of table of values. I've given you 4 coordinates. You could be given 3 coordinates, 2 coordinates. You can't just look at the slope of a line based on 1 pair of coordinates though. So you've got to have a minimum of 2. Keep that in mind. So once again, we're talking about the change in y compared to the change in x. The change in y compared to the change in x. My y's are changing as I go down the table. The question is, how are they changing? To go from a -3 to a +3, how much am I changing? I am increasing by 6. To go from a 3 down to a -9, I'm decreasing by 12. And then to go from a 9 to a 0, I'm increasing by 9. You see how the y values are changing as I go down my table? This represents how they are changing. By 6, by -12, then by 9. Then I'm going to change gears and look at the left-hand side. The 5 to the 7 is increasing by 2. To go from a 7 to a 3, I'm decreasing by 4. To go from a 3 to a 6, I'm increasing by 3. Now, if we're going to make a comparison of the change in y compared to the change in x, now I'm going to take a look at how those values are compared to each other. So I'm going to continue like this. Looking at the slope as delta y over delta x, the change in y over the change of x, I'm going to write down each one of these changes 3 separate times. So 6 compared to a -2, -12 compared to a -4, and 9 compared to a 3. Now those aren't the same, but that is a critical piece in analyzing slope. You need to make sure that the change in y to the change in x is the same amount. So when I compare this fraction 6 over 2, this fraction -12 over 4, and this fraction 9 over 3, they need to all simplify to the same amount. If they do, then that is what the slope is. If they don't simplify to the same amount, then that is not what the slope is. So notice that 6 over 2 reduces to 3 over 1, -12 over -4 reduces to 3 over 1, and 9 over 3 reduces to 3 over 1. So we'll say the slope for this example is 3. Now I'm writing a note at the bottom of this page. So if you want to take notes during this time, that would be wonderful. Just pause the video and write down whatever you think you'll need for future problems. You need to pay attention. Sometimes the values jump around as they did in this table. If that's the case, just make sure you reduce each ratio to the same value. All right, one more example. Again, 4 pair of coordinates. And we're going to find the slope of the line that is represented by this table. Here we go. First, we analyze the y values. We compare the change in y's and the change in x. So the change in y's go by -8, then by 3, then by 5. The changes in the x values increasing by 2, increasing by 3, and then increasing by 1. Now, let's compare the change in the y compared to the change in x. If I take my y value, -8, and write it over a 2, I will get -8 over 2 for my first change. The question is that the same as 3 over 3 and the same as 5 over 1? Well, hopefully you recognize by now that those fractions don't reduce to the same amount, the same value, so we can't find the slope in this instance. This table represents a situation that is not linear. When a function or when a table of values is not linear, that means it's not a straight line on a graph. I didn't have a graph to look at, so I didn't know. I had to compare by looking at the change in the y values compared to the change in the x values. So another little note for you to write down if you think it would be helpful. You need to pay attention. Once you've gotten all of your y values and all of your x value changes, then you need to compare the ratios and make sure they reduce to the same value. If they don't, then it's not linear and we can't say that it has a slope. Slope is only for linear or for lines. All right, now it's your turn. I'd like you to take this table and find the slope in the table using the method I did just a few minutes ago. Take the difference in the y's, the difference in the x's, and compare them. Pause the video, work the problem, and then press play and see if your work looks like my work. So here I found the change in y, the change in x, and then I compare the change in y to the change in x, and I find that the change in y is 6 throughout the table, the change in x throughout the table is -5, therefore we'll say the slope is -6 over 5. By the way, I want you to understand that I'm saying the slope is down 6, right 5. That's not to say that we can't put the negative with the 5 instead and say it's up 6, left 5. So keep in mind, you can put the negative sign with the top number or with the bottom number, but don't put it on both, because if you put it on both, it changes the value of the slope. All right, how about another one? Try this one. Your table of values 4, 3, 14, 7, 19, 9, and negative 1, 1. 4 pair of coordinates taken from a graph. The question is, what is the slope of the line represented by this table? Pause the video, give it a go, and then when you're done, press play and see if your work looks like mine. The change in the y's, 4, then 2, then negative 8. The change in the x's, 10, then 5, then negative 20. And then of course you've got to compare all of the y value changes to all of the x value changes and see if you get the same value. See if you get equivalent ratios. 4 over 10, both the 4 and the 10 can be divided by 2. Therefore, all of the fractions reduce to 2/5, so the slope is 2 over 5. That's up to right 5 if we were on a coordinate plane. All right, I think it'd be a good idea for you to try one more. This time I'm going to put a context to our problem. I want you to think of this table of values to represent how much time goes by and how many inches of a candle is burnt over time. So on the left-hand column, I want you to think of these values right here as time in hours. So 0 hours, 2 hours have passed, 4 hours have passed, 6 hours have passed. In the right-hand column, I want you thinking about how many inches the candle is tall. So in the beginning, the candle is 12 inches tall. After 2 hours, it's 9 inches tall. After 4 hours, it's 6 inches tall. And after 6 hours, it's 3 inches tall. And I'm asking you to find the slope represented in this situation. So pause the video, give it a go. Okay, as I work it out, I see the change in my y values, or the change in my dependent variable is negative 3, while the change in my independent variable is 2. So this time I'm thinking of the slope as not delta y over delta x, but delta inches, the change in inches, over the change in hours. The change in inches was negative 3, and the change of hours was 2. So that means the slope should be negative 3 over 2, or you could say negative 1.5. Now, when a problem has meaning to it, when it has a context, you should always make sense of your slope. So when I say the slope is negative 3 over 2, and you're thinking of the top number as being inches and the bottom number is in hours, then you should be able to interpret the slope by saying down 3 for every 2, or down 3 inches for every 2 hours. Does that make sense? I hope so. So now I'm going to recap for you, just a review, and if you want to take notes, go ahead and do it, but surely you've already done it in class. This is just a reminder for how to find the slope from a table. First, find the difference between each value going down the table. Then, write a ratio that stands for the change in y to the change in x. Then, reduce all your fractions and make sure they all match. Make sure you get equivalent ratios. And then that would be the slope. Make sense of it if it's in context. So now you know how to find the slope from a table of values. Good luck!